Okay, so I'm going to talk about the technology, and I think that, especially leading off the last presentation, the thing that's really important about our approach to actually having sensors and smart surfaces is that we're not using any esoteric materials. There's no requirements for any special capital investment of any form at all. It's actually part of the reason why I think a lot of people are confused about how incredible this is. Okay, my little tip. Anyway, so the critical thing about our technology is that it's just 3 layers. Okay, 3 layers that could be 3 layers of plastic, but this surface could either be plastic or glass. This is some form of film, or it could be air, depending on the application. And this is also just plastic. For the more technically orientated amongst you, consider both this layer and that layer to be like waveguides. Okay, flattened fiber optic strips, okay? And this layer here, its purpose is to ensure that as long as that surface is not disturbed, no light that's in that layer finds its way into this layer. What we do in the top layer is that we've got LEDs that are on the edges. And in this layer here, we've got photosensors, photodiodes on the edges, okay? This is an exploded view, so that in a collapsed state, the thickness could be down to, in total, a couple of millimeters thick, okay? Right, now, the thing about fiber optic cables is that information propagates because you're relying on the fact that the refractive index, the extent to which light bends in the material, surrounding the fiber optic cable is lower than that of the cable itself. And so what's actually happening here is we inject a light, actually from an industrial point of view, modulated infrared, and the light or infrared that's injected here stays there until you touch the surface. Okay? So it's contained by the concept of total internal reflection. You can look it up. When you touch the surface, what actually happens is you frustrate the total internal reflection, causing some of the light that's there to actually be directed through the separation layer and into the lower waveguide. And this is where it gets really cool. So this lower waveguide is lightly doped. It's lightly doped with something, say, like titanium dioxide, okay? The dopant that you use to color plastics. It's a really common or garden thing. But critically, those little dopants act like, to use an old-fashioned game, like, you know, pinball bats, and you actually bat some of the light to the edges. So the light, you know, is directed through here, goes into there, and then goes poof to the edges where it's sensed. Okay? Now, you know the position of the sensors. The sensors are measuring the intensity, and by virtue of having the registration from a minimum of 3 sensors with a known position and the intensity, you can actually work out the position. Okay? That's really it. And the patent is about the fact that you're using one layer to touch and another layer to sense. And because of the characteristic of the fact that it is wavelengths of light or infrared that you're playing with, one of the other beautiful things about this is that it's extremely sensitive to the amount of touch that's on the surface. I just want to make it clear, this is not a membrane, so you're not measuring newtons, you're not measuring pressure, you're translating between the amount of surface area that impinges on the surface, the deformation of the ridges of your fingertips, and the wetting that is a natural byproduct of the fact that people, you know, have moist or less moist fingers, okay? You know, if you have the opportunity, we can hook up some other time, but this is just incredible. It's just simple plastic, okay? To make this from an industrial point of view, is two-shot injection molded. You understand me? With nothing in the body, no conductive inks, no meshes, no allotropes of carbon, nothing at all. It's just plastic. This can be PMMA or polycarbonate, yeah? This can be a similar material that is lightly doped. This can be some fluorinated polymer or some other film. It's incredibly cheap to make. You've then got a sparse number of LEDs, and they're incredibly cheap, and the photosensors too. So that's it, really, okay? And because this technology is based on similar principles to optical fibers, in the same way that light can propagate through an optical fiber that's curved, light can propagate through a curved surface, okay? But unlike the limitations of optical fiber, where in order for the signal to go from one side to the other, you have to respect the concept of a critical angle, which is a function of the thickness of the optical fiber. In this case, this is a zonal technology. What we can do is decide this will be an active area, this isn't. This can be an active area, that isn't. Which means you can have any shape you want, okay? This is what's powerful. And this is what plays into design freedom, yeah? So people can sculpture whatever shape that they want with a plastic, right? They can determine which parts of the plastic is active or inactive. The other thing is that you can have extrusions and indentations in the surface. You can have ridges, you can have all sorts of stuff in that surface that actually makes it possible to feel your way along. That's how we're able to mimic, you know, dials, buttons, sliders. By the way, we can even embed in this, and we have got patents for that as well, you know, the old-fashioned iDrive dial stuff, okay? But frankly speaking, the companies we're talking about, most of them don't care about that. They just love the fact that this technology helps you to fuse between touch sense paradigm and the conventional physical paradigm. And you can integrate haptics, you can integrate whatever other, you know, sensors or actuators you want, because you're just putting it in plastics or glass. I'm really sorry for spending so much time on this, but if we even just stop here, that's more than enough. But there's more. So, this gives you a sense of the kind of things that we're enabling. So now you've got the collapsed laminate, you've got touch print and zoom, you've got the possibility of integrating either mechanical features or, as I said, just having extrusions, indentations, etc., etc. You can have iPod-like, for those of a generation, sort of radii and annuluses in there. You can have over-the-air gestures, because what you can do is you can project upwards into the air the LEDs, and therefore you have a shadow, and then you move your fingers along, and so you can do swipes, yeah? They're more sophisticated, it can be things that can be done, but you'd probably collaborate with, say, one of our colleagues like Ultraleap to do something much more fancy. Nevertheless, this technology performs a platform by which you can do that integration. And all I'm trying to highlight here is you can abut displays, icons, illuminations. You can even have illuminations coming in from the side. There's so many things you can do with this stuff. Okay? Oops, right. Running out of time. So hence why we talk about, you know, beautiful, intuitive, robust, safe, and economic. For the purpose of this talk, we're anchored around intuitive and safe. And in addition to the generic stuff that we're talking about intuitive and safe, what's highly relevant to automotive is the fact that by virtue of being able to create physical structures on the surface, you move away from having this flat surface that you have no sensation of where you are on that surface. Okay, that's what's really, really critical about this tech. Okay, there's a lot of marketing, blah, blah, blah. I take all the blame for that. This is my favorite slide. That just says we're awesome. Okay, so you can't have a pitch without speaking to this. So the size of this sphere is to basically say that what we're actually doing is supporting a rich range of HMI features. But just so that it's understand that it's not just an egotistical perspective, to make that happen, it's about partnership, yeah? It's working with people who do haptics and a variety of other things to actually make that as big as it can be, yeah? These competitors can't do that. And even the companies, for example, who do injection molded electronics are starting to shift their emphasis to working with us. And the reason why is because there's been a big hoo-ha and discussion about injection molded electronics. This is the idea that you injection mold and you embed in the mold, you know, semiconductors. But there are, because of the pressurization and temperature implications of forming and molding, the problem then becomes that you need to have semiconductors that are able to withstand that process. That's true of any conductive ink or metal mesh or anything else, which has both yield implications in terms of making smart surfaces based on IME, injection molded electronics, and it has reliability issues afterwards. And that's part of the reason why you're not seeing a proliferation of smart surfaces based on IME. There's a lot of talk about it, there's a lot of blah, 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 there's lots of communities gathering together to try to do something. But so far, the challenges are related to you know, reliability and yield. That's in a nutshell. Okay. And I wanted to add this because I just basically want to say that, that it's not just a fantasy about how we're perceived. This is just a subset of the level of interest. So we've actually, in Q1, announced a relationship with Hyundai. And basically, Hyundai spotted us when we really were just a lot of hot air. Yeah? We had nothing to show Hyundai. But in July of 2019, a few months after I came on board, I was contacted by Hyundai. I went to see them, did a pitch to them, but then subsequently worked out that we'd lose Hyundai's interest if we didn't do something remarkable. We did something really remarkable. And then they basically said, right, we'd like to work out a way of partnering with you. So, and now we are embarked on a proof of concept with them. And at the same time, what they're doing is hawking us around the various BUs to explore the possibility of which series that we could actually be integrated into. And in the case of Grupo Antolin, they're an automotive tier 1, okay? Not many people know them, but they are, in their own way, quite distinguished. Apparently, 1 in 3 of all automobiles shipped worldwide has a GA component in it, or product. They are specialists in decorative trim, and our partnership is about making decorative trim functional. Because the same sorts of processes that they, Faurecia, Yangfeng, etc., are using in terms of injection molding, etc., is a slam dunk to just have a subtle tweak, and then we can make it smart. That's kind of where we're coming from. So that's Hyundai and Grupo Antolin. There's a number of others that are anonymized. I'm really looking forward to an announcement before the end of this year about, I would say, the most iconic automotive company in the whole wide world. They're really hot for what we're doing, and I went to their sites, we presented to them. It was a joy to see 30 to 40 of their engineers, marketing people, everyone, hovering around the demo, playing with the demo, and then within 2 weeks of that, we got the agreement to go to work together. So that's really amazing. And I would say that I'm more than happy to just end here, because we can talk about a lot of other things. This blah, blah, blah is really to highlight the fact that we're fundraising. We're looking for £8 million. We should close that within this year. This is not a pitch to ask for money. We're actually good. We're oversubscribed, but never say never. So if you're actually desperate and you really want to come on board, off you go. But the thing I really want to say, which is what I'm very much concerned about and why I'm working with, Gunny, Alan, and some of the rest of you, is that I really want to try to build something or be a part of something where leveraging the capabilities of some of you here, we can actually do something outstanding together, okay? So this doesn't have the cachet of graphene or quantum computing or a variety of other things. This is a country that has this obsession about always the next thing in the future, and I admire the people for working on it. But here in front of you right now, there's something that's low tech from a manufacturing point of view, highly sophisticated in terms of back-end algorithms and electronics. The whole system bill of materials is cheap as chips, and this can go everywhere, absolutely everywhere. So I really think we should be joining hands and getting on with it. Okay, that's it.